we're going to be doing solving equations involving nth roots in this video. So what you will learn in this video, you're going to learn how to solve using the nth roots. You're going to be applying odd root property and also applying the even root property. The odd root property, so if n is an odd positive integer, here n represents the index, x raised to n is equal to a constant k. It is also equivalent to x is equal to the nth root of k for any real number. Okay, so let's look at more examples. So let's find the real solutions of this equation. So first step, we're going to divide both sides by 4. So what is left in here is just going to be x raised to 5 is equal to 32. Then we're going to raise both sides to the fifth root. So this is going to be cancelled out, and what is left in here is only the x, and in here is going to be the fifth root of 32. Now what is the fifth root of 32? The fifth root of 32 is 2. That means you're going to multiply 2 5 times and you're going to get 32. Now let's do a recheck. Let's recheck. The original equation says it's going to be 4x5 is equal to 128. So 4 multiplied by 2 raised to 5, okay, is it equal to 128. So 4 times 32 is equal to 128. Yes, 4 times 32, we know that 4 times 32 is going to give you 128 is equal to 128, therefore it's correct. So let's find the real solution to this equation using the odd root property. So the first step we're going to be doing here is to raise both to their third roots. So that's going to cancel out. What is left on this side is just going to be the x, and here it's going to be the cube root of 27. Now, if you're going to find the cube root of 27, it's going to give you 3. That means to say that you're going to multiply 3 times, and it's going to give you 27. Now, the best way to do that is always do a recheck. Okay, so recheck. Your original equation says that x cubed is equal to 27. Now, what is the value of our x? It's 3. So 3 cubed is it equal to 27? Okay, 3 raised to 3 is equal to 27. Therefore, it's 27. 27 both sides. That's gonna be correct. Here's another one example. So the very first thing I'm gonna do with this is to subtract 32 on both sides. Therefore, this is going to be cancelled out. What is left here is only x5 is equal to negative 32. Now I'm going to raise it to its fifth root of both sides. This will be cancelling out, and what is left is just going to be x in here, and it's going to be the fifth root of negative 32. Now since this is an odd root, we're going to only have one root in here, so that's going to give you negative 2. So it means to say that if you're going to multiply negative 2 5 times, you're going to get negative 32. Here's another one. So the very first thing I'm gonna do is to raise both sides to the cube root. Okay, that's going to be cancelled out. So what is left in here is just going to be x minus 2 is equal to the cube root of 24. Now, remember that 24 is the same as 8 times 3. Now, 8 is a perfect cube. Okay, let's continue. Therefore, we're going to plus 2 here, and then plus 2 in here. So this is going to be cancelled out. What is left now is the value of your x, which is 2 plus, let's say the cube root of 24 is the same as 8 times 3. So here we go. 2 plus the cube root of 8 is it's going to give you 2, and then the cube root of 3. That is the answer to this one. Even root property. Suppose n is a positive even integer. Now, first condition, if k, which represents the radicand, is greater than 0, then it is equivalent to x is equal to plus or minus the nth root of your k. So that means it has two real roots. The second condition is if your radicand k is exactly equal to 0, then it's going to be like x equal to 0. And the third is if your k is less than 0, that means it has no real solution. Okay, so let's look at some examples. Solve the equation. X squared is equal to 10. So we're going to get the square root of both sides. So what is left now is just going to be x is equal to plus or minus the square root of 10. So here you can see that your k is greater than 0. That means that your x is equal to plus or minus the nth root of your k. That's what we said earlier. Here we're going to get the 8th root of each side. Okay, so what is left now is just going to be y is equal to the 8th root of 0. And the 8th root of 0 is just 0. Y is equal to 0. Okay, the third one. The third one, I'm going to get the 4th root of each side. So if you're going to be looking at it, here, what happens here is that x is equal to the 4th root of negative 4. So what did we say? Your radicand here, negative 4, is less than 0. Therefore, this has no solution at all. So no solution. Okay, here's another one. Let's solve this equation. So the very first thing I'm going to do is to get the square root of both sides. So that's going to give you x minus 3 is equal to plus or minus 2. So I have two answers here. X is either 2 plus 3 or x is equal to negative 2 plus 3. Here x is equal to 5 and the other side is going to be x is equal to 1. So given this fact, now the solution set now here is going to be 1 and 5. Here's another one. So the first thing I'm going to do is to add 1 both sides. Therefore, that's going to give you x4 is equal to 81. And I'm going to get the 4th root of each side. Cancel out. So that's going to give you x is equal to the 4th root of 81. Now remember that our index here is even, therefore we're expecting 2 outcomes. So now, what is the 4th root of 81? The 4th root of 81 is 3. It's either plus or minus 3. So the solution set, if we're going to be looking at the solution set in here, is going to be coming from negative 3 to 3. That is the solution set.